Welcome to the JEE Mains Solution 2020. Let us take a look at the first question. In this question, we are having a pulley of mass m and a string is wound over the pulley, and to the free end of the string, we are having a block of mass m, which is the same as the mass of the pulley attached. Now, we have to find the angular velocity attained by the pulley by the time the block moves a distance h. So this is an easy question, which is an application level combined from conservation of energy as well as rotational dynamics. The pulley rotates as the mass moves downwards due to the gravity. Now, why pulley rotates is due to the tension providing a torque about the axis of the pulley. Now, to solve this problem, we can use the conservation of energy, that is, loss of potential energy is equal to gain in kinetic energy. The potential energy lost is mgh, will be gained by the mass, the block of mass which moves downwards. So it attains velocity v as it falls down through a vertical height h. And as the pulley rotates due to the torque provided by the tension in the string, we have the rotational kinetic energy as half I omega square. Now, we have to find the angular velocity omega. So we'll use the relation of angular velocity and linear velocity, which is equal to v equal to omega r. Now, using that here, we half m will replace v with omega r, so that v square becomes omega square r square plus half. I is the moment of inertia of this pulley, which can be considered as a disk which is rotating about an axis passing through its center perpendicular to its plane, which will be mr square by 2. So half I omega square. Now we will combine this to write it as 3 by 4 m omega square r square is equal to mgh. Since we want to find omega, rearranging, we have omega square is equal to 4gh divided by 3r square. Now omega will be square root of this quantity, root of 4gh divided by 3r square. Rearranging, we have the answer as option 1. In this question, we are having three masses, 1 kg, 1.5 kg and 2.5 kg, placed at three corners of a right angle triangle as shown. We have to find the position of the center of mass with respect to the 1 kilogram mass. This is an easy question. We have to imagine a coordinate system. Let us take 1 kg mass as the origin, so that we are having an x and y axis. So it is easy to locate the position of center of mass from the equation xcm, the x coordinate of the center of mass, is equal to summation mixi divided by summation mi, which is equal to m1x1 plus m2x2 plus m3x3 divided by m1 plus m2 plus m3. Similarly, the y coordinate of the center of mass of this system can be written as summation miyi divided by summation mi, which is m1y1 plus m2y2 plus m3y3. Now, what are x1, y1, z1, etc.? The position coordinates. Here it is a two-dimensional system, so we are having only x and y coordinates. So since 1 kilogram mass is at the origin, its position coordinates are 0, 0. Since 1.5 kg is along the x-axis at a distance 3 centimeter, its position coordinate is 3, 0. and 2.5 kilogram mass is along the y-axis. So the x-coordinate is 0, so its position coordinates are 0, 4. Now, xcm is equal to m1 x1 plus m2, say 1.5, multiplied by its position coordinate m2x2 plus m3x3, which is 2.5 multiplied by its position coordinate, which is of course 0, divided by sum of the masses, which is 2.5 plus 1.5 plus 1. So that makes 2.5, 4 plus 1, 5. Similarly, YCM is equal to, say, M1, Y1, which is 0, so 1 multiplied by 0, plus 1.5 multiplied by 0, plus we have 2.5 multiplied by 4, divided by the sum of the masses. From this, we have 1.5 multiplied by 3 divided by 5, which is 4.5 divided by 3. Sorry, 4.5 divided by 5, which is 0.9 centimeter. So the x-coordinate of the center of mass is 0.9 centimeter. So y coordinate of the center of mass is obtained by 2.5 times 4 divided by 5, which is 2 centimeter. So xcm is 0.9 centimeter and ycm is 2 centimeter. So with respect to the 1 kilogram mass, the center of mass of this given system is 0.9 centimeters towards the right of 1 kg mass and 2 centimeter above, means the answer is option 2. In this question, the second minima in a single slit diffraction experiment is obtained at 60 degree. We have to find the angular position of the first minima. So in a single slit diffraction, let this be the slit of width A. Light moves into the second region, and this is the position for the central maxima. So let this be the first minima. Let this be the second minima. So this is the angular position of the first minima, and this is the angular position of the second minima. The general equation for the nth minima is given by A sine theta n is equal to n lambda, where theta 1, theta 2, theta 3, etc. the angular position of the first, second, third, etc. minimas. So according to the given question, the second minima is formed at an angle 60 degree. So A sine 60, which is root 3 by 2, is equal to 2 lambda. So from this equation, we can have lambda by 2 is equal to root 3 divided by 4. Now, to find the angular position of the first minima, we will use the same equation where n is equal to 1. So A sine theta 1 is equal to lambda. So sine theta 1 is equal to lambda divided by A. There is a slight mistake here. So it is a lambda by A is equal to root of 3 by 4. Now from this relation, sine theta 1 is equal to lambda by A, which is root 3 divided by 4. Now root 3 is 1.732, and that divided by 4 is giving an answer which is approximately equal to 0.4. We know that sine 30 is 0.5. So the angle which gives the sine function, sine of that angle which is equal to 0.4, sine inverse 0.4 must be an angle which is close to 30 degree but slightly less than that. And from the given options, the best option is 25 degree, which is option 1. In this question, we are having two infinite plate of charge having surface charge density plus sigma, which are inclined to each other at an angle 30 degree. We have to find the electric field intensity at an arbitrary point P. The direction of electric field should be in terms of the position coordinate represented as positive x direction and positive y direction as shown. The electric field at a point due to a thin sheet of charge is sigma by 2 epsilon 0. So we can say that there is an electric field directed away from the first sheet, so the horizontal one, as E is equal to sigma by 2 epsilon naught. There is another electric field directed away from the second inclined sheet of same magnitude, sigma by 2 epsilon naught. We have to find the resultant electric field intensity. This is done by vector application. We have to resolve the electric field in a particular direction. Let us see how. So this is the electric field due to the inclined sheet of charge. Now, from the figure, if we imagine a line parallel to the inclined sheet of charge, we have an angle 30 degree here, so that the angle will be total 90 degrees. So this is 60 degree, the angle made by the electric field of the inclined plane with respect to the horizontal is 60 degree. So this can be resolved into two mutually perpendicular components by rectangular resolution of vectors, as its cosine component, that is E cos 60, directed in negative x direction, and the sine component directed in negative y direction, where theta is 60 degree. The resultant electric field due to these two thin sheets of charge will be the resultant of these two electric fields. So that will be the x component and y component. So the component of electric field along x direction is towards the negative x direction, which is E cos 60 in negative x direction, with E cos 60 in negative x direction, plus the resultant direction, the resultant electric field in the y direction. Now we can see that due to the horizontal plate, the electric field is towards positive x direction, which is E. So there is a component of electric field in the negative y direction due to the inclined plate, which is the sine component E sine 60. So E minus E sine 60 in the y direction. Since E is equal to sigma over 2 epsilon naught, so it will be sigma over 2 epsilon naught cos 60, which is 1 by 2 in the negative x direction, plus E, that is sigma by 2 epsilon naught, minus E sine 60, which is sigma by 2 epsilon naught sine 60 is root 3 by 2 in y direction. Simplifying, the resultant electric field is equal to which is option 1. Stay tuned for more JEE problems on physics.